Welcome to Millionlights. My name is Pratik Shah. I am an assistant professor in DY Patil School of Engineering. In the previous module, we had discussed about introduction to robotics, how a robot can be moved, how it goes forward, backward. We have done all this manually. And in this module, we are going to bring this concept into reality. We are going to use Arduino, and then with the help of programming, we'll do all these things. In this module, we'll make the robot move forward, backward by programming and all the various other things. Now let's start with the experiment. Before that, I would like to show you the robot that we are going to use. In the previous module, we had discussed about this robot. Here, we have got two wheels which are connected to the motors, and from those two motors, I have brought this jumper wires out. So with the help of these, we can give supply and the required direction. Now, these two motors are to be driven by L293D. Now, the use of L293D is already discussed in the previous modules. So, we need L293D and all these things because they are required for connections. Now, we'll start with what? We'll start with connecting this L293D to this motor. As you know that L293D can be used to connect two motors and it can be used to control them by using Arduino. So, we'll be developing the concept based on this. Here I have prepared a presentation in which the circuit diagram is explained. Now, if you take a look at this, I have got Arduino on my left hand side and L293D is there on the right hand side. Now to this L293D, what I am going to do is I am going to connect two motors. This is M1, this is M2. The M1 motor is on the left hand side, that is this motor, and M2 motor is this motor, that is on the right hand side. So to L293D IC, I am connecting two motors. These two motors are connected at the pin number 3 and pin number 6. So pin number 3 and pin number 6 is used for connecting first motor, that is on the left hand side, and motor number second is connected for pin number 14 and pin number 11. So these two motors are connected to these pins respectively, and now we have to take care that to drive these two motors we have to provide input to the L293D. Now input to L293D is provided by Arduino. So the left motor is controlled by Arduino's pin number 3 and 4. Pin number 3 from Arduino is connected to pin number 2 of L293D, and pin number 4 of Arduino is connected to pin number 7 of L293D. So Arduino from its pin number 3 and 4 will give commands to our L293D, and L293D will give the supply to the motor that is on the left hand side. So if I want to make the motor to move, the left hand side motor to move forward, then I have to do the programming accordingly. Now same thing for the right hand side motor. Now I have connected pin number 5 and pin number 6 from Arduino. So the pin number 5 is going to pin number 15 of my L293D, and pin number 6 is going to pin number 10 of L293D. So the connections are quite simple. We require two motors and those are connected to L293D, and for controlling them we require the signaling, and the signaling is provided by Arduino. So pin number 3 and 4 connected to the left hand side motor, pin number 5 and 6 connected to the right hand side motor. So with this we cover with 4 pins of our IC. Now we'll see the remaining pins. As I have told you earlier, we have got enable 1 at pin number 1 and enable 2 at pin number 9. So if you are using only one motor, which we did in the previous module, so we had given VCC to enable 1 only, and enable 2 was left as it is because we are not using the second side, that is right side of the IC. So here what we are going to do is we are going to connect enable 1, that is pin number 1, as well as enable 2, that is pin number 9, both to VCC because we are using both the sides and we are connecting two motors. So enable we have to give, and if you don't give, then this IC will not work and this will not give the desired results. Okay, so depending upon the number of motors you are connecting, you have to provide the enable signal. So here you can see enable 1, that is pin number 1 of the IC, and pin number 9 of the IC, both are connected and they are given to 5 volts, that is VCC from the Arduino board. Okay, so we are done with enable. Now we can see that pin number 4 and 5, they are 0 volts, that is they are ground pins. So I have connected them together and I have connected it to the circuit ground of the Arduino. Okay, so same thing is there at pin number 12 and 13. They are also ground pins on the right hand side of the IC. They were not connected in the previous module because we are using only one motor. Here we are using 2 motors, so we have to connect all the 16 pins. Hence pin number 12 and 13, they are connected together and they are also given to the ground terminal of the Arduino board. So this is also done. Now we have covered all the parts on the left hand side. Just one thing is left, that is 8th number pin, that is V plus motor, and this is given with the supply or the external power supply that you want to connect. So in our case we are connecting a 9-volt battery, so the positive terminal of that 9-volt battery is to be connected to pin number 8, as you can see in the schematic, and the ground of that IC, ground of that power supply is to be connected to the common ground. Okay, so with this we are covering the left hand side part, that is pin number 1 to 8. Now in the right hand side part also you can see all the things are covered except one, and that is pin number 16, that is plus V. Plus V means the voltage, supply voltage that is to be provided to it for operation, and that is what, that is 5 volts. Then that 5 volts is to be given from Arduino pin. So once again we have to take care that pin number 8 is the power supply, external power supply, and pin number 16 is the supply voltage of 5 volts that is to be given for this IC to be operational. So I hope that this part is clear. Now what we can do is we can take the apparatus and we can start assembling the circuit, and then we'll see the results. Now let's start connecting the circuit. Before that, I would like to tell you that I have placed breadboard on top of it, and this breadboard is connected onto it. That is, I have pasted it with the help of double-sided glue. Then I am using this IC. I have placed this IC on top of it. Then one more thing that I have done is I have connected this battery also here, because I don't want my breadboard to be moving. I don't want my battery to be moving. Therefore, I have kept these things constant. I have connected them. Now, if you want, you can connect to your Arduino board on top of it also, but I have kept it free. If you want, you can do that. Now for this experiment, what we are requiring, we'll be requiring a breadboard, L293D IC, external power supply, a robotic framework, of course we require that with 2 motors and wheels. Then I require this Arduino, because this is the main thing that will be controlling it. Then for connecting our power supply, we require this cap, jumper wires are required, and finally USB cable is required so that we connect Arduino with the PC. Okay, so this framework is there. Now what I'll do is, first of all I'll connect this cap to the battery. Okay, so I have connected the cap to the battery, and yes, so this is kept. Now second thing that we'll do is, we'll take our Arduino and we'll fix the position. So if I select this position, I can fix it onto the breadboard, or else I can keep it floating. For now I am keeping it as it is. Then we'll start with making the actual connections. Okay, so first connection that we'll be doing is connecting enable to VCC. So I'll be connecting it to VCC in here. So for connecting it to VCC, I have connected it on the left hand side slot of my breadboard, but here I have to provide a VCC rail. So for that, what I'll do is I'll use Arduino 1, 2, 3, 4. I'll use VCC that is available on Arduino, and I'll make a VCC rail here. So this is my VCC rail. Similarly, I'll also make a ground vertical rail on here. So I'm connecting the ground pins, and this is my ground layer. So this one is ground and this one is VCC. So now what I have done is I have connected enable to VCC. Similarly, I'll do with pin number 16. I'll connect pin number 16 to VCC because it is required to power the IC. Okay, then I'll connect pin number 9, that is enable to. So I'll connect pin number 9, that is enable to VCC. Okay, so these 3 VCC connections we have done, 1, 2, 3. Okay, so these are the only 3 VCC connections that are required. Now we'll start with connecting the ground pins. You can see that pin number 4 and 5 are ground pins. So 1, 2, 3, 4. Pin number 4 is to be connected to the ground. then pin number 5, that is also to be connected to ground, and in the same way we have to connect pin number and 12 and 13 to ground. So here we have 9, 10, 11, 12. So pin number 12 is to be connected to ground, and pin number 13. So this is pin number 13, that is to be connected to ground. Okay, so we are done with all the VCC and ground connections. Now only one VCC and ground is left, that is of the power supply, which we will be doing at the last. Okay, now let's see what is next. Next thing that we'll be doing is connecting pin number 2 on the IC and pin number 7 on the IC to Arduino. So pin number 2 of the IC goes to pin number 3 of Arduino. So this is 0, this is 1, this is 2, this is 3. Okay, so this is ground pin, let it be. Okay, now we have to connect pin number 7 of the IC to pin number 4 of Arduino. So this goes here. So this is 3, 4. We have connected left hand side motor. Now we'll connect the right hand side motor input to Arduino, that is pin number 15. Pin number 10 is connected to pin number 6 and pin number 15 is connected to pin number 5. So first what we'll do is we'll connect pin number 15 to pin number 5. Okay, that is done. Then we have to connect pin number 10, that is the second pin, to pin number 6. So we have completed the input section of it. Now we have to connect the motors and power supplies. Okay, so now regarding motors, these are the two motors corresponding to left side, these are the two pins corresponding to right side. This is positive terminal, so I have to connect this to pin number 3. I have to connect this to pin number 3 in here. Okay, and I have to connect this to pin number 6. So 1, 2 and 3, done. Now this is to be done same with the right hand side pin. This is to be connected at pin number 14. So this is 1, 2 and this is 3. Okay, so I have to connect it here. There are a lot of wires, so it might be a bit difficult, but you can manage it if you follow the circuit diagram. And then we have to connect pin number 11 to the this out. This is pin number 11. Okay, so with this we have connected all the inputs and motors. Now the final thing that is left is connecting the power supply. This is positive terminal of your battery and it goes on to pin number 8. So we can directly connect it to pin number 8. Then finally the thing that is left is this ground terminal of the battery. We have to connect this ground terminal to this circuit ground. Okay, so 1, 2, 3, 4, 5. Now this is the complete circuit diagram. Now we have to write the program according to it. You have to remember one thing: pin number 3, 4, 5, 6. 3, 4, 5, 6, and they are connected from Arduino to your IC. Now you have to just remember these things: 3, 4, 5, 6. If you give positive to 3 and negative to 4, same thing, 5 you give positive and 6 you give negative, then you are giving same polarities to the motors and both motors will move clockwise direction, that is they will move forward. So you have to remember that thing: 3, 4, 5, 6 in the same order. So based on that you can do any programming and you can make it move in any direction. So in the next part we'll see the programming of it. The circuit is built, just what we have to do is we have to connect it with USB cable to the PC, and after that when we write the program we'll see the results. Okay, so with this we complete the circuit part. Now let's see the programming. Let's see the programming of it. Now here my output is expected to move robot forward 2 seconds, then it will stop there and it will come backwards for 2 seconds, and this thing is continuously repeated. So what I want is, I want these two motors to be in forward condition for 2 seconds. So for that I have to give input to my L293D IC that they both will be moving in forward direction, that is in same clockwise direction. So I have to write a program according to it. So this is the program for that. First thing that we are doing is void setup. In that we are declaring the 4 pins that we are using. We are using pin number 3, 4, 5, 6. 3, 4 are used as an output, 5, 6 is also used as an output. So that is void setup. Now we'll talk about void loop. In void loop what we have to do is, we have to move the motor or move the robot for 2 seconds in the forward direction. So first we have to tell it to move in a forward direction. For it to move in forward direction, we have to write what? We have to make pin number 3 of our Arduino high and pin number 4 to be low, so that it will move in forward direction. And the same thing is to be followed with pin number 5 and 6, because that is controlling the second motor. So pin number 3 is high, 4 is low, 5 is high, 6 is low. So these 4 instructions come simultaneously, then our robot will start moving in forward direction. After that it will continuously move in forward direction. So we have to specify a time limit for which it should be moving in forward direction. Hence I have written a delay of 2 seconds. So it will make sure that it moves forward for 2 seconds only. But for it to stop, it won't stop after 2 seconds. I want it to stop. Therefore I have to write that instruction also. Hence after that what I have done is digital write 3 low, 4 low, 5 low, 6 low. That means what? 3, 4, 5, 6 all are set to low. That means what? The robot will stop. Then I have a delay of 1 second. That means the robot will move forward for 2 seconds, then I am stopping it. And if I don't write a delay after that, what will happen? It will stop and immediately it will follow the next instruction, which is to bring it backwards. And we never do all these things simultaneously. You don't tell it to go forward and come back at the same time. We need to give it some delay. So after stopping it, you need to provide a delay. Hence I make it go forward, then I want it to stop for 1 second. After that I want it to come back, and after it comes back, then also I will have a delay of 1 second. So how it is done? It is done in the opposite way, as if when we wanted it to go forward, 3 was high, 4 was low. Here it will be reverse. 3 will be low, 4 will be high. 5 will be low, 6 will be high. So it will come in backward direction. After that I write a delay for 2 seconds, so it will come back for 2 seconds, and then I want it to stop. So when I want it to stop, I have to make 3, 4, 5, 6 all low, and then there is a delay. So the process is go forward for 2 seconds, stop there, come back for 2 seconds, stop here, and both the times when it stops the delay is of 1 second. So I hope the code is quite simple. It is just having digital writes and delays. So this is clear, I think. Now what we'll do is, we'll compile the code, we'll check whether it's correct, we'll upload it, and we'll see how it actually works. I have written the code onto the Arduino IDE. Now let's compile it, and if it's working, we'll upload it onto the board. Before that, what we'll do is, we'll connect it with the help of this USB. So first I'll connect it to PC. Now this time around I have opened it because we require a lot of space for the robot to be moving. Okay, so I connect it in here. Okay, so now this is connected. Okay, now I'll upload the code. Okay, it's getting uploaded, and yes, the robot is moving very properly. So it's going forward, coming backward, it goes forward, waits for a second, come back, then once again it waits. So this is working as we intended. So there is no flaw, no glitch ups, and no problem at all. Now in the previous part we had seen that our robot goes forward and comes backward. Now what if we want to make it to move on the right hand side? As in the previous module we have discussed, there are two types of right hand side turn. One is soft right, second one is hard right. In soft right what happens is, one motor is stationary, the second one is moving. Okay, so now what I want to do is, I want to make this robot move on the right hand side. So my right hand side motor will be halted, that is will be stopped. So it will have both the signals low, and the left hand side, this motor will be active. So and it will be moving in a forward direction. So I have to set 3 and 4 as high and low, and 5, 6 will be low. So if I write the code accordingly, it will work in the same way. So let's see the thing. This is the code. I have already typed the code. Same thing will be there in void setup in all the codes, because we are using 3 and 4 as outputs and no other thing is used. Therefore void setup will be same. In void loop, what we'll have is, first thing that we want to do is we want to make this bot move on the right hand side. So 3, 4 will be high low, 5, 6 will be low low. So this will move on the right hand side. Now after instructing it, it will start rotating on the right hand side. But if I don't write any instruction after that, it will keep on rotating. It will be making a circle of itself. So what I'm doing is, I'm telling it to move on the right hand side, and after that I'm giving a delay of 2 seconds. So it will be rotating on the right hand side just for 2 seconds. After that I'm making all the motors stop. For making all the motors stop, what I'm doing is detail write 3, 4, 5, 6, low, 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 low. That's it. And after that I'm giving a delay of 90 seconds, that is 1.5 minutes. That is because if I don't give a delay, then the thing is, it will start moving on for 2 seconds, it will stop, then 1 second it will start moving. So for that purpose I'm giving a delay of 1.5 minutes. So what is the output? Output is this robot moving on the right hand side. It will be taking a soft right turn for 2 seconds. After that it will be stopping. So now this code, I'll upload this code and we'll see what the output is. Okay, so it's uploaded. That's it. So it's moving for 2 seconds. Now it is stopped. It will be stopped for 1.5 minutes because I have written the code in the same way. Now if you want to take a look at it once again, what I can do is, I can press the reset. When I press the reset button, what happens? The loop runs once again. So the code is once again executed. That's it. So with the help of this, you can do as many things as you can. Now once again I would like to take you to see this. Now this motor is stationary, only this motor is rotating. Okay, therefore the turning radius is quite a bit more. Now in the same code, what we'll do is, we'll remove the stopping part. Means what? In loop we'll just make 3 high, 4 low and rest all low. So what will happen? This will rotate continuously on the right hand side. In the previous case we wanted it to rotate for just 2 seconds, and after that we made it to stop. But now we'll remove all those delays and we'll make it to rotate on the right hand side. Okay, so what I'll do is, in this code I'll delete this part. I'll delete the delay part, I'll delete all the stopping part, and I'll upload it. Okay. So after uploading, we can see the expected output. Okay. Yes. Now this will continuously rotate. This will be continuously moving on the right hand side, and you can see that this is stationary and this is moving. Stationary and moving. So this is happening continuously. I didn't wanted it to happen, therefore I made it to rotate for just 2 seconds, and after that I had a delay on it. Okay, so this is it. Now what we'll do is, we'll talk about the hard write and we'll see how it works in a different manner. Now what we'll do is, we have seen the soft right turn. Now we'll do the hard right turn. In hard right turn, both the motors will be active. The left motor will be moving in the forward direction and the right motor will be moving in backward direction. So in the same area, it will be rotating. So if I give a 2-second delay, in the previous case you saw that it was rotating for 90 degree. In the same code, if I give a 2-second delay, it will cover more than 90 degrees. Now we'll see the code and then we'll see the output. First, in the code we have void setup is same traditional orthodox thing, which is having pin 3, pin 4, pin 5, pin 6 all as outputs. Then here 3 is high, 4 is low, so that left motor is moving in forward direction. Then I'm giving pin number 5 and 6 and reverse directional movement. 5 is low, 6 is high, so it is moving in backward direction. So in the same time both motors are active and the delay is of 2 seconds. So in 2 seconds a lot of area will be covered compared to the previous model. So what I'll do is I'll upload the code and we'll see the output. Okay. Okay, so in this you have seen that both motors are moving and it has covered a lot of area in less time. So the time duration for it was also 2 seconds and the previous soft write was also 2 seconds. But the area covered is more. I'll once again reset it and then we can see both the motors are moving and the area covered is more than 90 degrees. That is, in same time we are covering lot more area. This both motors are rotating in the same time. Okay, so this was doing for just 2 seconds. Now what I'll do is I'll remove the delay and I'll make it rotate continuously so that we can see in how much less radius it covers maximum distance. Okay, now we have seen that we had made it to rotate for just 2 seconds. Now I'll keep that time delay off. I'll make it to rotate continuously so that we can see how exactly hard right turn works. So for that I'll remove all these delay parts and yes, I have removed it. Now I'll upload the code and then we will be able to see the output. Okay, so it's uploading. Okay, right. So you can see that it is rotating on its place. Both the motors are moving. The left hand side is moving bidirectionally, that is in forward direction, and it is going in backward direction. So it is not, the turning radius is quite less and in very small amount of time a huge amount of area is covered. Now we'll take a soft left turn. Soft right turn we have taken, we'll take a soft left turn. In that the robot will be moving on the left hand side. For that the second motor will be moving and this motor will be stationary. So according to that I have written this code, and this setup part is same as the previous one. It will be same for this module all the time. Then in the void loop what I have done is I have made the left hand side motor off and the right hand side motor is moving in forward direction. Then I have given a delay of 2 seconds. I'll upload the code onto the bot and then we'll see how it happens. Okay, so the code is getting uploaded and it is taking a bit of time. It will get uploaded eventually. Okay, so now it will move on the left hand side. Okay, so you can see that this motor is stationary and the another one is moving. So after 2 seconds it is having a delay, hence it is not doing any action. If you want it to be free flowing, what you can do is you can remove the delay and then it will be continuously rotating on the left hand side. So this was soft left. Now we'll see the hard left. Now we'll take the hard left turn. For hard left turn what we are doing is the right hand side motor will move in forward direction and left hand side motor will move in backward direction. So I have written the code already. Now I'll upload the code. The code is getting uploaded. Yes, so this is what the output looks like. It is covering more than 90-degree area because both the motors are moving simultaneously. Okay. This is what the output is. Now one more interesting that we can do is we will make it freely rotating. Now what I'll do is I'll delete this delay parts so that instead of rotating it for 2 seconds, what we'll do is we'll rotate it continuously on the left hand side part. Now we'll see how the output looks like. Okay, okay, now you can see that both the motors are moving, therefore in a very less area a lot of portion is covered. In this video we have done a lot of basic stuff on robotics. I hope you liked the video. If you have any queries, you can find us on Facebook by the name Millionlights, or even on Twitter. You can visit our website www.millionlights.org for more such interesting courses. Thank you.